Hello, everyone. Welcome to the binary episode of the Day Zero podcast. I'm Spectre, with me is Z. This will be our last podcast until September 19th and 20th, when we'll be returning from our summer break. We'll still be around in the Discord and whatnot, but the podcast won't be running, so that's just a quick heads up there. In today's episode, we have some Fuchsia OS hacking stuff, a printer bug detailed by Synactive, some Radare2 issues, and some bugs in Windows drivers. Before any of that, though, let's cover the Spot the Vuln challenge as always, which I'll pass off to C.
Yeah, and this week's Spot the Vuln, it's something that honestly I haven't seen a lot in real code, but I did come across it once and it's kind of stuck with me since. Core issue that should kind of stand out. Obviously unserialized is being used here, so that's always kind of a risky sync to see. In terms of what's getting passed into it, well, the original data does get serialized correctly, and I left that in a comment, so it's nothing too crazy there. While it's serialized correctly, there is this little block in the middle here, the for each, that the idea there being that you're trying to block some words or something, and you're just replacing the pattern, whatever the pattern is. I mean, I've got a couple examples up at the top here, but replacing a pattern with the series of 5 asterisks. The problem with that is that if it matches something smaller or bigger, just different sized from the 5 asterisks, then the actual serialized data is, which includes what the byte count is. So like you'll have like S and then colon like 10, and then you'll have 10 character bytes following it, and then it'll see another thing for like whatever other object, and it kind of reads along by following the byte count that's provided. So because of this replace, the size of the string will get messed up, and you can end up having it where it'll jump. Especially in this case where we have like FBI's only 3 characters being swapped out for 5, it's going to jump to like 2 characters before the end of the actual string. And look there for the start. So if you have a few words there, have this happen a few times, like multiple terms getting matched or whatever, you can move it further and further along, basically giving yourself room to start creating your own object to be deserialized because it thinks it's at the end of the original string, even though it's not. And basically leading into a deserialization issue.
I like how you had FBI, CIA, and NSA in the block list. I imagine that's going to be pretty effective. So
yeah, I added the block list, so if you actually watch last stream, and actually I think on the starting soon, I forgot to update it. It doesn't actually have that function. I just figured I'd kind of include it as a hint towards the issue. 'Cause technically you don't control the block list, but it is a fair assumption, I think, that the block list would have a variety of sized words in it that aren't always just 5 characters. But I realized kind of after the fact that you might not catch the difference without seeing something there, so at least this way it shows that, and I guess chose the TLAs for it.
yeah, so I guess apologies to those who saw like the Spot the Vuln on yesterday's stream and tried to solve it there without seeing the updated image in Discord.
Well, it still would have been
So
solvable from that. It's just a bit of an extra hint as
yeah,
to where the issue comes from. Oh, I'll also mention that this is similar. This is a little bit of a hint for one of our 0x0539 challenges. Has kind of this vulnerability if you want to play around with it. And that is the temporary profile or temporary notes challenge.
all right, so with that out of the way, we'll get into some of our topics. Up first, we have bugs in the Radare2 disassembler, the disassembler that all the real hackers use, and I'll let Z get into the vulnerabilities here.
The disassembler that I believe last time we talked about it, we joked about just being able to pipe dev random into it and get a crash, and somebody in chat actually did so and got a crash. So a few more crashes in there. The first and the last one, so there's 3 crashes here. First and last one, they're no pointer dereferences, so I don't want to spend too long or really dive into them at all. The middle one here is a, a little bit interesting in what it's doing. Also just a little bit stupid in terms of writing the code. It calculates off the size t max size and just calculating that as like the max value between a couple things. And then to get the actual max size, it takes the minimum size, so whichever is smaller from that max size versus the file size itself. And it makes sense. Not going to read beyond the size of the file if that so allocates it based off of the size. The problem is when it actually goes to read data, it's still just using those original values, the cell refs. It doesn't read with that value, so it doesn't really matter. So if that value is larger than the file size, doesn't matter. Still going to try and go. And same issue actually is repeated a little bit later when using the ssconst value. So the idea there was just figure out what size buffer is needed in total, and just kind of failing at that.
It's kind of interesting that both of the first two issues are in code that's dealing with macOS stuff. You didn't really cover it because it was an null ref, but the first vulnerability was in the XNU kernel cache code for like loading buffers. And then the one you just covered is in obviously build refs. So yeah, it just seems like maybe the Mac OS side of things or analyzing Mac OS objects are just not as well audited or not as well cleaned up, I guess. The third vulnerability was in a separate area. It was in like the symbol parsing, but uh, yeah,
I
I
mean,
mean, code just seems pretty thoroughly not tested, and that's obviously highlighted by the fact that you could just pipe dev random to fuzz it into Radare. But like you were saying, the null derefs aren't really that interesting. Most modern systems are going to have null page guards, so they're not really going to be interesting from a security perspective. The heap of overflow would probably be interesting, though. I don't know for sure if you could exploit that because I've never tried to exploit Radare, but yeah, usually heap overflows are pretty useful primitives to have.
yeah, and they don't go too much into the exploitation side. I'm not even sure if I've really seen anything talking about exploiting some of the structures within there at all. Um, but yeah, I mean, it is a overflow with user controlled data and reasonably controllable size, so it feels like a pretty good setup for some that would be exploitable, especially given that there is a good degree of complexity within the actual application and like the available structures and things that would be sitting on the heap.
For sure. And disassemblers are kind of interesting targets from a security standpoint. Maybe not so much for Tare, because I don't think I know anybody who really uses it at this point. But um, obviously, the only people who are going to be using, well, I won't say the only people, but for the majority, the people who are going to be using disassembler tools like Radare are going to be security researchers, which are interesting targets when it comes to trying to exploit somebody. Um, and you could have some kind of vulnerability or exploit baked into a malware sample where it's like if the security researcher analyzes it, could pop their disassembler and maybe do something interesting. I don't know, it is a little bit far-fetched, but they are uniquely positioned products in terms of how useful they could be to exploit, to do targeted exploitation.
And we
um,
have seen a little
but
bit
yeah.
more in the past couple years about targeting security researchers. So, I mean, it is a tool that's used there, especially I mean, Gidra's kind of pushing towards that now too, but on the automation side, on the kind of like having a free tool to work with to release open source tooling around, like Radari does have some usage there. While it's not something I go to as like my main use case if I'm actually actively doing the disassembly, it is something that I've considered in the past for projects where I just want to hook into its API and stuff. Now, I mean, I'd probably use it with like Binja has a really good API and stuff, but I mean, in the past, it's definitely come up for that sort of use case. Just kind of being almost in like an automation flow. So, I mean, there are some places where this could come into effect or have an impact.
Yeah. But yeah, I mean, part of the reason we wanted to bring up this topic is just that it's fun to meme on Radari a little bit. So, and we haven't done it in a while. So, All right, so getting into some more serious vulnerabilities, though, we have a post by Synactive on some printer vulnerabilities that they exploited in Pwn to Own Austin 2021, which was apparently the first event that featured network printers. Which for some reason I thought they were in some of the previous competitions to that, but I guess they weren't.
Not sure
Um,
about printers, because we only really had the IoT coming up as a thing. What was that, like around with Miami in like 2020? I think might have been
yeah, that's true. It
2019.
was
So
pretty recent.
yeah,
Yeah. Um, yeah, I mean the prizes that were offered here were pretty decent for these printers. $20,000 US dollars and two master of pwn points. Now, as per usual with these types of IoT devices, they did have to do some RE, which is what the first half of this post is about. I'll mostly skip it here, though I do recommend checking it out if printers and these kinds of devices are interesting to you, as it is pretty cool. They talk about how they extracted the bootloader from the board through a few different ways. They could dump it from the embedded multimedia card, though the easier way they went with was to just set up a proxy with the admin panel to check for firmware updates and then pull the firmware updates that way. Seems there was no encryption really in use there. There was some obfuscation and signature checking, but the firmware wasn't encrypted with like a private key or something. So it was fairly easy as far as embedded devices go to pull the firmware. They then found a vulnerability in the CAD-M service, which is the Canon administration service, I believe, which ran on some public-facing TCP ports. They detail the structure of CAD-M messages, which consists of a magic, a header containing the things you'd expect, like version, flag, opcodes, whatever, which is then followed by a binary blob, which has structured data for whatever opcode was passed in. One opcode in particular had a buggy handler, which was the hex83 opcode for checking the user password. There, they expect a buffer that consists of three buffers with the length encoded in 1 byte perpended to it. So they expect like the password, the salt, and the hash. They have a diagram that kind of shows what's going on there. Um, I'll just kind of bring it up here. Yeah, Z already pulled it up. I'm guessing now the problem is that while the password length is checked, the salt and hash lengths are not checked. I'm guessing what's going on there is the password seemed like an obvious attacker controlled vector, but they just didn't really think about the salt or the hash for whatever reason. Um, they didn't really think of those being attacker controlled data. So, yeah, fairly straightforward vulnerability, just missing checks on the length there. Exploitation was a bit easier than standard heap exploitation as well, due to a custom allocator being used here by DryOS, which is Canon's real time operating system. They're able to do the old free list attack on the linked list because it seems their heap allocation was not hardened at all against that. So yeah, they
well,
could just smash the next entry to get an arbitrary allocation returned, which can give you a pretty standard arbitrary read write kind of primitive. So yeah.
yeah, like they kind of take its. I wouldn't say it's a standard free list attack. Standard free list attack is where you go after the pointer rights when it unlinks the unlink attack, where when you control the
Yeah.
back and forward pointers, and then while it's unlinking it, it's going to write to like it's going to write the forward point. I'm going to confuse myself, try think through the mental aspects, but doing the link list work there where it's trying to rewrite the pointers will end up basically giving you this arbitrary right. In this case, what they did is it feels a little bit more similar to House of Spirit, where with House of Spirit it is a different attack completely, but the primitive you get feels a little bit similar. House of Spirit, you pass in or it's where you can pass in an arbitrary pointer to free, so you get like your own block sitting on the free list, get it allocated, and now you're able to go in right there. Similar deal here, but they corrupt that next pointer. Pointing in the right place. And then when you get an allocation later, I think Spectre will be getting to how they did that. So I'll leave that to you. But when they get the allocation later, they get that sitting wherever they want it to, wherever they wrote that next pointer to. So a little bit different than the kind of old free list attack, but still kind of has some base in those old House of attacks.
Yeah. Yeah, it's not exactly like the old thing with like the free list attack like you were talking about, but it's kind of the same idea. You're attacking the next pointer to get an arbitrary allocation back. Um, yeah, I wasn't going to cover too much of the exploit, like the heap exploitation there with how they did the fragmentation and the subsequent allocation. Um, I was mostly going to talk about the post exploitation because I thought that was a little bit more interesting. Um, because well, okay, I'll jump back a little bit. Um, they use the heap overflow here to overwrite the handler for the echo request, got it pointed to some shellcode, and then got an echo packet sent to trigger the shellcode. It seems there was no like data execution prevention or anything in place here, so there was no like ROP or any super complex exploit chain needed there. The post exploitation was pretty cool too. To Pocket, they basically decided to make the shellcode display Synactive's logo on the printer LCD. So they did a little bit of reversing on the frame buffer to figure out how that worked. Wired up a TCP socket that would read a picture sent over. But yeah, that post exploitation like POC is kind of cool, taking advantage of like the unique nature of the device and yeah, displaying the logo like that. I thought that was neat.
I'd have expected them to print a calculator picture, but
You could have
I
done that
mean,
too. Missed opportunity, yeah.
I'm sure
Plopping
that would
calc
have
on the
taken
device.
quite a bit more effort. Or
Probably.
perhaps not even needed much effort, because I mean, you can print regardless. It's a printer.
Yeah.
No, it was good, but yeah, I don't know. Like, I don't know if Pwn to Own actually had any rules regarding what like the proof of concept would be. Because I think in other areas, like they do have the expectation of like popping calc. Um, Although maybe that isn't actually baked into the rules. That's just tradition. I'm not sure.
Yeah, I'm not intimately familiar with the Pondone submission process and what they have to prove, like how they have to prove it. So yeah, can't really comment there. But overall, I mean, I think it's a pretty good post. They go into a good amount of detail here on like all the steps. Like I said, I mostly skipped over the first half where they do like the bootloader analysis. But for people interested in like firmware stuff, it's a very cool part of the post. They have some really nice diagrams. They talk about how they go through bin walk to try to reverse the structure and everything. It's a pretty cool section of it. But yeah, not super relevant for the vulnerability. It was just kind of the initial groundwork they had to do to be able to find vulnerabilities. So, but definitely a cool part of the post as well. All right, so we'll get into our next post here, which is by Alexander Popov on Fuchsia OS and its Zircon microkernel or Zircon-based microkernel, as well as exploiting a synthetic vulnerability found in it, but there's also a real one there too. Fuchsia, for those not familiar, is Google's newer open source OS that's been in development for years now. They're hoping to eventually have it replace Linux as the operating system for Android, though it's a ways away from that. I think it is used in production on some devices, like their Nest Hub, but it's not widely deployed at this point. It's still fairly early in development, as part of this blog post will show. So yeah, as you can guess, with Google being behind it and where they want it used, security is a major focus of Fuchsia. And playing into that, they're also using microkernel architecture. It's also capability based as opposed to user based. So they have like limiting attack surface kind of in mind in the design. Although as far as microkernels go, Zircon does have quite a lot of syscalls. I think they said it has like 170 or something. Um, so like the idea here is you'll have some stuff in the kernel still, like IPC, memory management, scheduling, the kinds of things you would expect in the kernel. But then other things like various drivers and networking stuff, that's all moved to user space, to reduce the kernel attack surface. So it's kind of an interesting operating system to look at. It's pretty different than most of the other ones that are like active in development. Um, so yeah, Alex goes on to getting a development environment up and running a Fuchsia emulator. He tried running syscaller for Fuchsia, which syscaller does technically have support for, but it's very shaky. He couldn't really get it to work. Couldn't get it to build really.
Well, I think
Um,
his conclusion was kind of that Syscaller used to have support, and like I think his last commit there was like 2020, and basically doesn't anymore. Like couldn't get working there. I
yeah,
don't think Sysbot runs that either, so there's also a fair chance that it just doesn't have support anymore. And because of the changes, even that old commit just really didn't work. Because, well, I guess it might have worked if he was willing to put in the effort to update all of the definitions for it. He mentions that enough has kind of changed in the OS. That said, I did want to jump back a little bit and just comment generally on Fuchsia, in that it is the microkernel aspect is something I've always found interesting when it comes to the exploitation, because that does really change a lot of how you're going to approach the privs, because basically what you have a vulnerability and it's going to have a huge impact on what you can access, and you kind of need to jump around through different components to get more privileges or to get other privileges, even not necessarily more, just having other privileges until you're able to kind of hit the kernel, unless of course you have a vulnerability right and something easy on the kernel. I don't know, it's just kind of stood out to me as being an interesting place to experiment with, because there aren't a lot of systems that are running microkernels. I think the Switch is the last thing that really comes to mind as being with the microkernel.
Yep, Switch is the only like modern system I can think of that runs one. And yeah, like you said, it's very interesting from a security architecture perspective because typically in a microkernel setup, you have a lot more layers that you have to get through. So your chains end up longer because, yeah, you're going to have less areas where you can just jump directly to the kernel from some unprivileged um, application or user because that's kind of the whole point of the security part of microkernel design. Um, but yeah, so yeah, Fuchsia's pretty interesting there. Um, like I was saying, unfortunately, they couldn't really get syscaller working. I do find it a bit interesting that the syscaller support is so outdated and not being actively maintained. Uh, like I was saying, Fuchsia is a Google maintained project. Syscaller is also Google maintained, and I would think that fuzzing would be they would want it actively integrated in the development of such an operating system.
That
But
was my thought too. So I've heard about Fuchsia. I know, like I said, I've heard that they're using it with some things, like maybe with some Chrome OS stuff, or at least maybe some code. I'm not sure, but it's been one of those things. Like I've heard rumbling about it, kind of coming and being worked on, and so yeah, it does surprise me that maybe they have some in-house fuzzing things. I mean, Go is used on this too. I'm not sure to what degree. I just know Go's involved, and Go, pretty easy to fuzz with, and basically fuzzing built into the language to an extent. If you define the test interfaces, but ignoring that, like, it is surprising that syscaller didn't work. I was quite surprised by that. One, because having looked at syscaller, I've seen the fact there was some, or it was implied that Fuchsia worked, but I don't know. The thing that surprised me is just how not production ready the whole thing seems, at least compared to what I'd expect from Google.
yep, which we have some stuff coming up on about that too. So yes, since they couldn't really get syscaller working, they just decided to introduce a synthetic vulnerability to kind of demonstrate and experiment with how exploitation would work in Fuchsia. Um, the bug they introduced was a pretty straightforward UAF on the timer dispatch. They added a condition where if the deadline divided by like 100 or like a million or whatever gave a remainder of 31,337, it would delete the timer object even if it wasn't released yet. So just trying to introduce a UAF that would be hittable in some conditions, but not all the time. So if you fuzzed it for a while, you would eventually stumble on it. Um, Here they talk about trying to exploit that UAF, finding a heap spray or reallocation primitive. They ended up going with the FIFO objects in Zircon for IPC, which Alex mentions. Like IPC is the most common form of like heap spraying on pretty much any kernel because it's a great way to get your own controlled data into a buffer, and you typically control the size and stuff. So it has some optimal conditions for that. Um, since Fuchsia is C++ here instead of just C like the Linux kernel, exploitation was made a little bit easier here actually, because instead of trying to find some object with like a function table or something like that, the C++ objects have B tables and such. So it was a pretty straightforward vector to go to code execution. I'm guessing there was no forward edge protection because it's not mentioned here. So yeah, I'm guessing there's no CFI or anything in play, which is a little bit surprising, but maybe not so much when we get into the next part,
Yeah,
because
although on that note, even if there was, when you're dealing with CFI, especially in the C++, because of all the indirection that happens with objects, my understanding is there's some significant difficulties with getting um or basically having that without introducing or maybe not introducing, but without still exposing quite a few gadgets. And I know the co-op attack, counterfeit object oriented programming, I think, is like C++ CFI bypass based around like abusing the virtual tables or virtual calls and all of that. So, oh no, I think there are some challenges with that. I haven't looked into it super recently, so Perhaps I am somewhat mistaken on that, but I believe there are some extra challenges with CFI in C++ code because of all of the indirection that happens.
Yeah, that's a fair call out. So obviously, when you're talking about attacking pointers like this, the first thing that comes to mind is ASLR. You're going to think that's going to stop you. You're likely going to need some kind of info leak primitive to be able to fake pointers properly. The somewhat obvious place to look for such leaks, especially in a new operating system, is in the kernel log. Normally, this log is supposed to be protected and not reachable from unprivileged code for exactly this reason. They don't want any sensitive information getting to unprivileged code. Though Alex ended up finding a bug that did let them read the log, and that was through this xz debug log create syscall. With this syscall, you're supposed to give it a resource kind, and the docs state that you're supposed to give it a resource kind root. But Alex kind of thought, like, what happened if you just didn't do that? So instead of passing the kind root, he passed the flag readable resource, and that just allowed him to open the log. Now, this idea of resources is a little bit unique to Fuchsia 2, I believe. And Z, I know you dug into this, so I'll let you talk about that a bit here.
Yeah, so just to actually talk about the core bug, I believe when they show the code here, it's basically it has this if statement if resource is not equal to ZX handle invalid, then it does the root check. And otherwise it basically just carries on. If you if you give it an invalid handle. So I'm not what I didn't look at was if the ZX log flag readable actually or no, so he passes in the root resource, which is effectively just the global variable that's initialized to 0. Okay. So it basically passes through there, passes through this check. They just like if it's invalid, keep going. But on the topic of resource, I did think that was an interesting thing, and I was trying to look into what was it really expecting here and what is a root resource. And I found that what they're doing in Fuchsia is first of all, the resources are kind of a very lower level concept. Like even the drivers shouldn't really need to be using this too much. It's going to be passed out to like the well, the bus drivers would have it, but like your generic drivers wouldn't. Um, but it is effectively the way that they're passing along writes to certain memory regions. Because what it would have is the resource along with the type would have things like the base and then a size saying like here's a base address plus this many bytes the size. That's what this resource is allowed to access. And to create a new resource, you can only create like subtypes of resources that you've had. The exceptions kind of being root and hypervisor is another one. Um, that are kind of treated as special and just like in this case it's supposed to be a capability check. They don't have any size or anything associated with them, but I did think like the general idea here of using the resource in this way to hand down the access to different memory regions was just an interesting aspect to like the security they've got going on here. Obviously, this particular bug class, it really didn't matter because you can bypass it. But yeah, I just thought that was an interesting approach to it because you are able, depending on how often and frequently you're checking what resources are owned and all of that, um, you kind of create that sort of inheritance aspect, and you're not able to create resource into memory you shouldn't have access to. So, oh no, I only looked into it very briefly, so I may have some misunderstandings there, but from a glance, it looked like an interesting aspect.
Yeah, so I was talking to Zeal about this a little bit before we went live, but this system reminds me a little bit of like a cross between SE Linux and how resources are handled, and like heap sandboxing. Um, so it seems to be kind of borrowing ideas from different things and putting them together in an interesting way. I don't think I've ever seen like this kind of mitigation or this kind of design in a different device or something. So yeah, it was pretty cool to be able to get some insights on this and exposure to it through this blog post.
Yeah, and
Um,
in fairness, like one thing that I'm not sure about is exactly how these get passed around or how this impacts like where this gets checked. It's like the resource types are things like the MMIO or like IRQ on 86 stuff. Um, So I'm not sure exactly if it would reflect well, like if you can relate it with the heap sandboxing. I get where you're coming from, but like my understanding is limited that I'm not entirely sure if that's accurate or not. Like I don't know how these things are getting checked beyond really this case that we're looking at.
That's fair.
So
So
don't take what we're talking about as like this is how Fuchsia works, because frankly I don't know. I'm just talking about what I read in a couple hours before the podcast.
yeah, it's kind of an actively developed kernel too, so it could change pretty easily. It's not really like a stable release like Linux or something. Um, so yeah, we just went through all of that about how like these resources work and how this bug exists, where because of this logic bug, they just like don't even check it really. The funny thing is, they didn't even need to do any of this because after getting the log and attempting exploits across multiple boots, they noticed the pointers they were leaking weren't changing, and that's because ASLR didn't even work. So, um, yeah, I mean ASLR was enabled, but because of like the way their boot memory configuration works, it just it doesn't work. This was a known issue to like the Google team when it was reported. I think they said that they're planning to address this with like basically the current way they have memory set up in the boot process won't allow ASLR to work properly. It'll break things. So they're planning to like refactor the boot code, and that's when they'll try to make it work. But yeah, like Alex says here, this was a bit of a shock and kind of demonstrates how early in development Fuchsia still is. So yeah, it's not really anything close to production ready at this point,
Yeah,
at
this
least from a
was
security perspective.
when I made the comment earlier about feeling like it's not really production ready. This is exactly what I was thinking of, like not even having ASLR for something that's generally considered to be a like security oriented operating system. Not even having that just seems like a huge red flag that, things are still needing to be worked on.
Yeah. So from there, exploitation was fairly straightforward. They were able to fake a vtable, hijack code execution. They talk a little bit about post exploitation, installing a rootkit. For that, they've just smashed the syscall table after disabling rate protection and installed their own syscall. Kind of a standard way to go about it. Well, it is a little bit noisy, but it's probably the easiest way you can get a form of persistence in the runtime. But yeah, kind of a funny post because, like I said at the beginning, Fuchsia is supposedly designed with security in mind, but exploitation here was fairly easy in comparison to like the Linux kernel because of the lack of mitigations or lack of working mitigations, and because of the fact you're dealing with C++ here. Like Z was saying, C++, you have a lot of indirection going on. There's a lot more interesting targets you can overwrite inside of even like more benign objects. So yeah, a bit of an interesting operating system to look at. I think as time goes on, we will see more research into Fuchsia. At the moment, it's pretty. There's just not a lot about it because it's not really being used anywhere yet outside of like the Nest Hub. But when it starts getting closer to a state where they want to start pushing it on Android and stuff, there will be a lot more research into this kernel. So good to get a bit of a head start on it and just see a little bit of what's going on in the design philosophy and how it's architected. So yeah, really good post from Alex. All right, so our last post we have is by CyberArk on finding bugs in Windows drivers, which is a bit of a long post as it goes into background on how the Windows driver model or WDM works, and some of the things you need to be aware of there. I'll mostly skip that as it is getting a little bit too into the technicals of Windows specifics. The way they have the post laid out is they basically demonstrate a type of bug that could exist. They talk about some of the API basics, and then they demonstrate one or two vulns in a real world driver. I'll mostly just stick to the real world vulns to keep it, somewhat short. The first bug they demonstrate is a bug in the Azure VFP extension by Microsoft, or VFPX.sys, and it has to do with how ioctls work. This one is a little weird if you're not familiar with Windows, because it is kind of unique in how it handles ioctls compared to like Unix. Basically, ioctls have a transfer type that can be associated with them. So you have method neither, method buffered, and method in and out direct. Method neither basically tells the IO manager not to do any checks on buffers or their lengths. They're not copied into kernel controlled buffers, and it essentially gives the user full control over the data buffer that's going into the kernel. Because of that, it's a pretty dangerous method to use. It's a red flag if you see a driver using or allowing method neither. Method buffered is the more preferred way of doing things, which is it'll copy the input and output buffers into kernel managed memory. So the buffers can't be paged out or changed or anything. And the input and output buffer pointer is assigned to the associated IRP or IO request packet. The direct methods are pretty similar to buffered. They allocate the input buffer the same as buffered. Output uses the same buffer after probing and such. For all intents and purposes, for this post and the vulnerabilities, buffered and direct are kind of the same thing. The thing is that the IRP is only allocated if you pass a method of buffered or direct. It doesn't really mean anything for method neither, and thus it doesn't populate it. So that's where this first bug comes into play. It's basically a null deref. If you set neither, the IRP system buffer is never set, and this SX start device IO control method will just directly reference the system buffer for doing Unicode string stuff, and that'll blue screen. Not really that interesting of a bug. It's just a denial of service. You can't really do anything cool with it, but they do kind of call it out. I believe Microsoft also didn't want to address that vulnerability, which is a little weird because this would be like a really easy fix, but their argument is just the impact isn't high enough, so they don't care. But yeah. The next bug is a little bit more interesting, though maybe not quite as much as we are in Windows land, and they are a lot more frequent to come by. And that's because it is an info disclosure or an info leak. This is in the Realtek RTS per.sys driver. I'm just trying to bring it up here. Yeah, this one is fairly straightforward as far as info leaks go. It's basically your most obvious case. This one uses method buffered for the ioctl, so the system buffer will get copied back out to the user. Problem is the system buffer doesn't get initialized beyond the copy of the input buffer. So if you have an output buffer length that's larger than the input buffer, there's uninitialized data that gets leaked there. Kind of your most standard form of info leak. They just don't zero the entire buffer or zero any of the buffer. So whatever you don't initialize as an input will just be stale memory. The last bug they detail is in an unnamed driver, and really it just seems to be a blatantly dangerous ioctl as they allow user parameters passed into memmove. So I'll just bring it up here. Yeah, so it's in an image, so unfortunately it's hard to really highlight the code. But in this hex 26 DC04 ioctl, it'll take a user-controlled size, source, and destination pointer, and it'll just pass it through to memmove, and thus can be used for arbitrary write. Similar, hex 26 DC08 will take user-controlled params for memmove, and can be used for arbitrary read, as the contents will be put back into the system buffer that gets returned. So, yeah, pretty powerful and straightforward bug. This is something you see sometimes in like anti-cheat drivers or like antivirus drivers. Usually it's exposed for some kind of like management utility, but it's just like not sandboxed properly, or not like the access control is just really shoddy on it. But yeah, these kinds of ioctls are just really stupid. um, yeah, it's a pretty straightforward exploit for that. So mainly some mean bugs in this blog post. What I'd take away from this post is the fact that the bugs in some Windows drivers can be some low-hanging fruit. If you're aware of the considerations you need to take in the kernel, particularly the Windows kernel, you can find some pretty funny things and easy to take advantage of things. That said, Windows is a little bit complex with how its API works, and you do need to understand some of the nuances to be able to catch some of these types of issues. And obviously, reversing is required. As you can see in this post, all of the code in this post is decompiled code because you don't have the source code. So there is a little bit of a barrier to entry there, but yeah, Windows drivers don't seem to be the the most well vetted or audited code out there. So you can find
Yeah,
some pretty funny bugs.
part of that definitely comes down to just how the Windows, I guess, drivers are basically fragmented. Everybody who wants to put out a driver just puts it out. Whereas over in Linux land, they're part of the kernel code in general. I mean, there are some third-party drivers, kernel or kernel modules that come out there, but like there is a little bit more of a centralized development. So when they want to update or fix or whatever, like it's all in one place to get fixed. Whereas this is just third parties putting out binary blobs. And that kind of just lends itself to uh bad code, I think. Just like, I mean, part of it is fragmentation, just like not really having standardized ways to do things, Windows not being able to enforce certain protections just in general because they need all of the driver creators to opt in and stuff. It creates those problems. Like they are, as you said before, these are kind of meme bugs, but they're bugs that absolutely exist in, you know, popular products. It's not like you need some random thing here. We've had some crazy bugs in like popular what was there was the one that like gave you access to the MSRs that we talked
Oh
about a
yeah, I
while
vaguely recall
back.
that. I
Yeah,
wish I
and it
remember what
was
episode that was.
yeah, it was like an Asus thing or something. Oh no, maybe it wasn't Asus, so don't take the brand, but like it was some pretty popular drivers. So the bugs are out there. Like if you want to find CVs and kernel, like it does feel like a good place to look is just finding a random driver and going at it. And that kind of ties into a question out of chat from Artisus Main. Hey there, I'm really new to kernels. Can you guide me where to start, gain knowledge into kernels? I'm pretty comfortable with C, and memory management. When you're saying kernels, I'm assuming because of the topic of the podcast, you're kind of asking about kernel exploitation and not just kernel development. Uh, in which case, I don't have a lot of solid resources I want to recommend. The first one that comes to mind though is just the book Tannenbaum's Modern Operating Systems. As a book, it's not so it follows like Minix or something like his own little learning. Well, I think he's taking it quite far, but his own little operating system. Kind of uses that as a basis, so it's not like accurate to what you're going to see, but it introduces the problems that you're going to run into, just that operating system need to deal with, the scheduler, all of that, just considerations that they need to have. And I think being aware of the problems, then when you actually start looking at other kernels and actually looking at implementation, you're aware of the problem, so you can look, well, how did they deal with it? Did they follow the normal pattern or whatever? Like, did they do some proper solution or did they hack and look for issues that way? So I think just helps having that foundation of that book. Windows internal series on Windows going specific into Windows stuff. Kind of has similar information too. A couple resources in terms of just practicing some exploitation. One is Linux focused. And that's from Xari, I think. Yeah. Just has a bunch of resources for kernel or Linux kernel exploitation. And the only thing that comes to mind for Windows, there might be more. I don't do much Windows myself, but Hacksys Extreme Vulnerable Driver seems like a pretty good starting place. I've heard it mentioned quite a few times, so I'll shout that out also.
Yeah, I will say, like, with getting into kernel exploitation, it's not like memory corruption is different between user mode and kernel. The fundamental concepts of like the types of vulnerabilities you'll find and how exploitation works transfers over. It's just the types of issues you'll find are a little different because the challenges you face are different. So, like Z was mentioning with the modern operating systems by Tannenbaum, it'll go through a lot of the producer and consumer problems and like synchronization issues, and that is one of the things you'll find a lot more in kernel compared to user mode is like synchronization, because pretty much any system in the last 20 years is going to be SMT. So you have to deal with like shared access to resources, so locking and RCU and things like that. And it's very easy to mess that up or have like one line that just is in the wrong place and thus can lead to some kind of memory corruption. Um, but yeah, like I was saying, like for the most part, the memory corruption transfers. It's just the types of issues and patterns you'll see are a little different. So for that reason, I don't think there's a lot of books specifically on kernel exploitation. There is one. There's like Attacking the Core Kernel Exploitation. I don't really think that's a good book. I'm not really going to recommend it. I think the better route is just to understand user mode exploitation, get comfortable with that, and then learn about the internals of the kernel through books like Modern Operating Systems or the Windows internals books if you're looking at Windows. And then you can kind of apply things from those two, like from exploitation and from the internals knowledge, and then apply those together to do kernel exploitation.
Yeah, and
Um,
I think I mean, that's kind of the general approach with anything on the exploit dev side, to start off with the basics of what is exploit dev and all of that, and then look at your specific target, because a lot of the concepts, as you're just saying, they apply. Like, software is software. Whether it's a Windows executable, Linux, Mac, like, you have the same concept, like a linked list and sorry, and like pointer issues in a linked list. It's the same thing across them. It's just your environment changes a bit. So like you can learn all the concepts just by looking at standard exploitation, then you apply it to some new context. Kernel does have a little bit of an interesting aspect on the exploitation side because of, well, the interface is a little bit different for one. But the other side of it is you're often not actually trying to get code execution in the kernel. You're trying to get a or a user space process with privileged or with extra privileges, usually like root or system or whatever. So it does change it a little bit because you're not just going for code execution. You can like try and ROP in the kernel and stuff. There are some techniques around that, but your goal is generally a little bit different too. Changes things, but yeah, I mean, yeah, I don't have a lot of good resource there just for that, but I think Spec you kind of hit, starting off with standard exploitation and then just learning a bit about the kernel, and obviously I've put a few resources for kernel specific stuff.
yeah, jumping back a bit, like you were saying, it does apply to every target, but the reason I kind of called it out with kernel is there is this common or seemingly common assumption that kernel is some kind of special, like it's not like any other software or something, which isn't quite true. There are special considerations, there are some unique challenges with it, but um, that's kind of true of other things too. Like if you go into browsers, there's going to be unique challenges and unique things you have to learn about that too. So um, yeah, that's going to be true of basically any modern target. But yeah, I'd say with kernel exploitation, the best, like the way that I really got into it was by looking at like existing vulnerabilities and trying to exploit them. Um, like just trying to go right away and try to find an ODE in something like a kernel when you haven't done it before is just not really. I mean, you can try it, but it's going to be really difficult, and you're probably going to lose motivation doing that. If you want to get comfortable with kernel, though, you can take a look at existing vulnerabilities, try to implement them, play around with them. Um, One of the other challenges I'll call out as well with kernel exploitation is introspection is quite limited, um, because debugging just sucks in the kernel. There's some people who have come to me like, how do you deal with things in like Unix kernels? Like, let's say the Linux kernel, do you debug? And I'm like, no, I rebuild the kernel and I use print debugging. And it sounds like a meme, but I actually do it because using GDB or something in the kernel it just sucks. And you basically need to do like virtualization and use like the GDB stub, and it just doesn't work that well. Windows, you're maybe in a bit of a better scenario there because WinDebug is pretty solid. But outside of WinDebug and maybe like iOS, if you're using um, why can't I think of the name? Z, can you get it for me?
I'm not sure where you're going with that. So,
The iOS emulation, we used to talk about it all the time, especially where it was in the news for a while. But for some reason, I can't. Oh, Corellium. Sorry,
yeah.
Corellium. I can't believe that escaped me. But yeah, so if you're in iOS, you kind of have Corellium, and Windows, you have WinDebug. But other than that, like if you're doing like BSD or Linux or something, uh, yeah, it is going to be something you're going to have to deal with, and you're probably going to have to use more hacky methods, we'll say,
I
for
mean, running
debugging.
under QEMU, uh, doing the debugging that way, I don't know. I don't find it that bad, but You prefer your print statements? I'll leave you to them.
I love my print statements.
And I
So,
did want to shout out, we also have a series of posts that's kind of about going from CTF style exploitation to real world stuff. The third one, we kind of talk about like dealing with some of the end day development, re-implementing old vulnerabilities as a way of gaining skills in a particular target. Like the whole series of posts is really about how do you go from I know the basics to actually targeting something, and the same process could absolutely apply to kernel versus a userland thing.
all right. So that's basically all that we have on the hard topics that we have for today. Z does have some things that he wants to shout out due to the fact that we're going to be gone for a little bit. So um, some of these will overlap with what was talked about in yesterday's bounty episode, but for those who missed it or just don't catch the bounty episodes, then yeah, I'll let Z go into shoutouts.
Yeah, I mean, as we're going on break for a while, if you're looking for a resource to kind of keep up with, you know, vulnerabilities being released or write ups being released in particular. Last year I put together this zerodayfans.com website. And this catches quite a few different blogs. It'll filter them a little bit, so it's trying to only get like VR or vulnerability research type write ups. It's not perfect by any sense, but there's quite a few blogs that it covers. So, I mean, refresh that every so often. You'll find a lot of the topics that we cover end up coming up on here too. Another resource is Maxwell Dullin's resources blog. He also has a blog, which is generally pretty good. Doesn't post super often, but it's there. But the resource page, he does summaries of exploits, pretty much like what we do, except in written form. Puts them out haphazardly. And there's web and binary stuff here, but he does cover some binary stuff, so it's at least worth checking out. And Bad Sector Labs, last week in security, has a lot of different things. Does have a little bit more of a network security push. It feels like in a lot of places, but there will be the binary exploits if they are there, you know, under techniques and write ups. You'll generally still find them getting listed. Like this one here has the parallels thing we covered uh last week or a couple weeks ago, and Connor McGar's recent exploit dev post. So like it's there, it's available. Just a few resources to follow up on while we're on our summer break.
And along that line, I also want to call out that we did some watch party streams of Offensive Con 2020, 2022, obviously. So if you haven't checked those out, they are up on our YouTube. The first day that we covered was Counter-Strike Global Offsets, which was exploiting Source Engine, as well as a talk on data-only sandbox escapes by Project Zero. And then the one last week that we covered had Samuel and Amy's talk on browser exploitation, attacking JavaScript engines in 2022, which was a really awesome talk, as well as Mark Dowd's talk on how do you actually find bugs, which wasn't quite as technical, but it went into more of like the methodology side of things, and it was pretty. It was a pretty inspiring talk. So. Yeah, I would recommend checking out those watch party streams if you miss them, or just talking out those, like just checking out those talks if you haven't seen them in general, even if you don't want to watch them for a watch party. They're pretty good talks. So yeah. Um, Other than that, though, that's pretty much everything that we have. Unless you have any last minute things, Z, we'll go ahead and wrap it up.
I guess one very quick last minute thing. We get this asked for every so often in chat. Hasn't been out for a while, but there has been a request for a beep, so I fulfilled that.
Oh, okay. There we go. A beep to send it off. All right. So, like I said, that's everything we have for today. Thank you, everyone who tuned in. The VOD will be up on YouTube and Spotify and other platforms tomorrow. Remember to follow our Twitter and join our Discord to join the community. This is our last podcast episode until September 19th and September 20th, when we'll be returning from the summer break. And as I said at the top of the episode, we will be around in the Discord and stuff, and we might do some other streams. But yeah, it's just the scheduled podcast won't be running. So, yeah, just be aware of that. And yeah, if you're just checking out the podcast, we'll see you after the break.